All right, so we've got this young child flying a kite horizontally 120, flying a kite horizontally 120 feet above the ground. Every second the child lets out 2.5 feet of string, and we want to assume that there's no sag in it, so it's it's perfectly straight. We want to know what's the speed of the kite as it's being let out. So we want to know like how far away is it moving from the child. Not necessarily like the height of the string, but moving along horizontally. So if you want to visualize this, so the height is going to stay constant at 120. That's what this problem is saying. We want to find this right here. We want to find the speed in which it's moving away from the child, whoever has this kite, But the parts that we do know is that we know that this is 2.5. The string is being let out at 2.5, and we know that it's at 130 right now, 130 feet. Okay, and so what I'm going to say, this length right here, the hypotenuse of this right triangle, I'm going to say is dh. Okay, so dh over dt is equal to 2.5, and then the h at this time is 130. And so, since we have a right triangle, let's use Pythagorean theorem again. Our h, or the hypotenuse, is going to equal the x squared times, or x squared plus the y squared, which is just, vertical horizontal. And now we're going to use, we're going to find the derivative of it, because we want to find dx over dt. And so that would be 2h dh over dt is equal to 2x dx over dt plus 2y dy over dt. Okay, and now we have different things we can plug in. Well, we know what dh is. We know what h is. Okay, h is 130. dh is 2.5. We know what 2 is. We know what x is. We still have to calculate that. And then we have our dx over dt, which is what we're trying to find. We know what y is, 120. And then what's dy over dt? Well, since we're not changing the height, it's always staying at 120. That would be 0. Okay. So we're just going to kind of forget about that. That part gets multiplied by 0 because we're not changing the height. We don't have to worry about it. Now the part that we're looking for is what x is. How long is this? Well, since we have our right triangle, 120, 130, and then this is x, we use 130 squared minus 120 squared. And that gets you x squared. Take the square root of them. Take the square root of both sides. Getting us our x is equal to approximately 50. Okay. So that means that our horizontal length is 50, so we're going to put a 50 here. Now that gets us after, since this is 0, we kind of forget about this. This is gone, that y part. And now we're going to divide by 2 times 50. The 2's cancel. Dividing this through, we get our dx over dt, or the change in the horizontal, is equal to 6.5. And then we're going to have our feet per second as our speed. Okay. So as you see, this one is dealing with a lot of right triangles, which is what we see a lot because it's nice and easy to deal with. So in this case, it's going to be in feet per second, and deal with a nice right triangle, and then just using kind of the distance formula to and the Pythagorean theorem to find our missing parts. Okay, and then once you identify and find everything, you can just kind of fill in the gaps, and it's kind of like putting together a formula. All right, so we've got an oil spill, like Exxon Valdez or the BP oil spill, but what we have is a ruptured tanker, so it's kind of like the Exxon Valdez one. If you don't know what that is, you kids should look that up because it's kind of sad that if you guys don't know about that. But oil spilled from a ruptured tank, spreads out in a circle okay, whose area is increasing at a constant rate of 6 miles squared per hour. How fast is the radius of the spill increasing when the area is at 9 miles squared? So, our rate of our area increasing, or dA over dt, would be equal to 6, because that's right here. That's telling us the rate in which the area is increasing. 6, obviously, so dA over dt is that. We know that our area, that for our final answer, we want to find it when the area is 9. Okay. And it's asking for how fast is the radius increasing, so we're asking for what's dr over dt. That's what we're kind of looking for. Alright, so if we have our area formula, A is equal to pi r squared. Okay. And now we take the derivative of it. Okay. So that would be dA over dt is equal to 2 pi r dr over dt. And now look at that. We've got the parts that we need basically kind of to fill in. We're looking for dr over dt. We know what dA over dt is, but now the next thing is, okay, well, we got to know what r is. Well, if we plug this 9 in here, 9 is equal to pi r squared, solve for it, we end up getting r being equal to 3 over the square root of pi. Okay, and I just divided by pi, and then I took the square root. Now that can be plugged in there. So after we plug all that cool jazz in, we end up getting 6 is equal to 2 pi times 3 over the root 3, or root pi, is equal to dr over dt. And now we want to solve for dr over dt, so we divide this stuff onto the other side. And that would get us dr over dt is equal to 6 divided by 2 pi times the reciprocal of that, which would be the square root of pi over 3. Well, this becomes 3 and 1. This becomes 1 and 1, leaving us with root pi over pi, which if we reduce that gets us dr over dt is equal to 1 over the square root of pi miles per hour. So that means that this oil spill is increasing, its radius is increasing at a rate when we're at 9 square miles. It's increasing at a rate of 1 over root pi miles per hour. Okay? Pretty simple. So that's, you know, a way to see, okay, well, how fast is this oil spill going to be going? How fast is it going to be increasing over a certain amount of time in an area that's given? All right. So ship A, which will be right here, this is ship A, is 15 miles east of point P and is moving west. Okay, so it's moving in this direction at 20 miles per hour. Okay, so right now, right off the bat, we can say that dA over dt is 20. Okay. Now ship B is down here at 60, and it's moving north at 15 miles per hour. So we can say that dB over dt is equal to 15. Okay, so I've decided to keep these in positive, which mean their speeds are positive, which means that their locations are going to be negative. So the first one would be negative 15, and the second one would be negative 60. Okay, and that's going to come into play when we plug these in to solve them. All right, and it wants to know at what rate is the distance between them changing after 1 hour. So where is A located? A's location after an hour is actually at positive 5 because we've kind of moved past P. And then B's location would be at negative 45, or negative 60 plus 15, or 15 minus 60. That's going to be the distance. So now we want to know at what rate are they changing. So we're going to be looking for the distance between them, which I will denote as dc over dt. Okay, dc. That's what we're going to be looking at. And as you can see here, we've got another Pythagorean theorem. We've got another right triangle. And so we'll have c squared is equal to a squared plus b squared. Okay, take the derivative of that, getting us 2c dc over dt is equal to 2a dA over dt plus 2b dB over dt. Okay. Now we want to solve for dc over dt. dc over dt is equal to a dt over dB or dt plus b dB over dt all over, and then I'm just going to jump straight into a squared plus b squared, square root of that, which is the distance, which is what c is, again. And so now we can see what we can plug in. Okay, so for dA over dt, we've got 20, and for a, we've got 5. So right now, we've got dc over dt is equal to 5 times 20 plus b is minus 45 times 15, which is dB over dt, all over the square root of 5 squared plus 45 squared, or a negative 45, but since we're squaring it, it turns positive. So the top part, we end up getting 100 minus 675. And then the bottom, we get the square root of 2050, which means we get a minus 575 all over a 45.2769 dot dot dot. It just keeps going and going. And then when we divide that through, we end up getting our dc, or our change in the distance between the two, is equal to negative 12.6996 miles per hour. And which means, since it's a negative, we are decreasing. So this speed is actually decreasing as we're moving, but if we were to keep going, it actually goes from decreasing into increasing. Once b passes up p, you start increasing again. And so there we go. So there's another example where we have ships in a boat crossing a point and seeing how far apart they are, and the distance between them changes as time moves on. Alright, so since we're on a roll, we're going to try to finish these up. So the first one is that we have a right cylinder. Okay, so just a normal cylinder, like a can of soup or a can of clams. A can of clams, haha. Okay, so we say that our radius of this cylinder is increasing at a rate of 2 inches per minute. So right off the bat, we know that our dr over dt, or the change in the radius, is 2. And then the next part says, and the height is decreasing at a rate of 3. So our dh over dt is minus 3. Okay. It wants to know what is the rate of the volume as it changes when r is 8 and our h is 12. Okay. So what we're trying to find is dv over dt. That is our goal, is to find what dv over dt is. Well, the volume of a cylinder is equal to the area of the base, which is pi r squared, a circle, times the height. Okay. So there's that. So now what we're going to do is that we're going to find the derivative of this. Okay. And our derivative would be dv over dt is equal to pi times, and now we've got to do a product rule. And our product rule would be 2r dr over dt, derivative of the first, times the second, plus the derivative of the second, which would just be dh over dt, times, dh over dt times the first. Okay. And now that we have these, we can plug in our numbers that we already know that we have. I mean, this one's pretty straightforward. with solving wise. dV over dt is equal to pi times 2 times 8 times dr over dt is 2, h is 12, okay, plus dh, which is negative 3, times the r, which is 8 squared. All right. So now we would multiply all those together, see what we get. Multiply, 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 multiply. We end up getting pi times 384 minus 192 is equal to dV over dt. And after we do some easy simplifying, we find that dV over dt is equal to 192 pi. 192 pi. So that means that the volume is changing at a rate of 192 pi inches cubed, okay, because we're dealing with volume, which means it's going to be cubed, inches cubed per minute. And there's our change in our volume for this cylinder that we have.